Hello and welcome to the second video in the Maths for Scientists series. My name is Mr. Douglas, and in this video we're going to be talking about converting units. So we're going to be starting by talking about converting times. We're going to start here because it's slightly different to what we do with almost every other unit, and it's something that our students should have been doing for a long time by the time they get to us, certainly at GCSE, but even by the time they get to us at Key Stage 3. We're then going to move on to talking about converting units that have prefixes, and we'll finish by talking about converting areas and volumes, which again, although they have prefixes, have a slightly more convoluted system for converting them. So starting with time, as I said already, converting time is something our students have been doing for, well, a long time. Therefore, they should be well practiced at doing it. At least for smaller time frames, talking about converting seconds to minutes, minutes to seconds, etc. There are some things we as teachers and students need to remember for converting time, and those are the basic statements that there are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, and this is the one that trips people up, particularly by the time they get to A-level physics. There are 365.25 days in a year. And the reason that there's 365.25 rather than just the classic 365 is that every 4 years we get that leap year, which is that extra day. So when we're talking about physics equations, we should account for that extra quarter of a day each year. And then finally, the final thing we need to think about with time is that all equations that use time must have time in seconds. I've put in brackets there usually because if we're talking about kilometers per hour, it's fine to have, or speed, distance, time equations where you're talking about kilometers per minute, etc., or meters per minute. You could use time in minutes, but almost always, certainly by the time any GCSE questions, etc., time will need to be in seconds. So what I've got here is just 4 practice questions for you to try. If you've got no idea how to do them, then don't pause and we'll go through the answers straight away. But if you want to have a go at doing them first, just pause, have a go at answering all of them, and then we'll go through the answers. So hopefully everyone who's watching has had a go at answering these questions. We're just going through this now. So we need to convert all these times into seconds. So to convert 41 minutes into seconds is easy. We just do 41 times 60 and we get 2,460. Then if we're converting 32 hours into seconds, well, we know that there are 60 minutes in an hour and 60 seconds in a minute, so we need to times it by 60 and times it by 60 again. And some teachers are often tempted to teach students that to convert from hours to seconds, you just times by 3,600, which is what 60 times 60 is. And it's fine to do that. However, I would suggest it's another thing that students have to remember on top of everything else they have to remember. They probably already know that there's 60 minutes in an hour and 60 seconds in a minute. So just teach them that they need to times by those two numbers independently would be my advice, rather than trying to get them to remember another number on top of all the other things they have to remember for their GCSE. But when we do that, we get 115,200 seconds. Then we've got to convert 19 days to seconds. So we know that there are 24 hours in a day, 60 minutes in an hour, and 60 seconds in a minute. So we do 19 times 24 times 60 times 60, and that gives us 1,641,600 seconds as an answer. And then finally, we're talking about 3 years. So we know that there are 365.25 days in a year, 24 hours in a day, 60 minutes in an hour, and 60 seconds in a minute. So we do 3 times 365.25 times 24 times 60 times 60, and in this case that gives us 94,672,800 seconds. And that really is all students need to be able to do for converting time. It might be that your exam starts talking about decades. I've never seen it. It doesn't mean it couldn't happen. So again, that might just be an explanation that if they do read the word decade, that means 10 years. But in general, these are the basic skills they need to practice. As long as they know how many of the thing below that kind of time increment is, they can work it out. So moving on then, we're now going to talk about prefixes. And at GCSE, students need to know and be able to use standard form for conversion of units. So it's easiest to do that for our prefixes that go all the way from giga all the way down to nano. So if you ever see something, so you might say gigameters, what that means is if you've got 1 gigameter, there is 1 billion meters there. And that's written as 1 with 9 zeros after it. Or alternatively, you could write it as 1 times 10 to the 9, which is much easier for students to write in a calculator. Again, with mega, that's 1 times 10 to the 6. It's the same as a million. Kilo is 1,000. And most people know that conversion is to get from meters to kilometers, you would times or divide by 1,000. And that's 10 to the 3. So what I would suggest with your students is you get them to remember the prefix column, the symbol for the prefix, and the standard form. It's perfectly okay to go through the meaning with them, but they don't really need to know it for their exams, and it's extra information for them to remember. So if you're focusing on just things for memorizing, think about the prefix, the symbol, and the standard form for that equation. And that's because when we're converting units, so if we go now, we've got some practice questions. If we're converting from 0.5 kilometers to meters, because we need to convert it to SI units, so the SI units for distance is meters, we need to think about how we can do that easily. So as I said already, lots of students already know that to convert from kilometers to meters, you times by 1,000. But kilometers is a very standard size of form that students already know. And it won't help them with the later on questions, like let's for instance say it was gigameters. So when we're converting, instead of thinking about saying, okay, to convert from kilometers to meters, we're going to times by 1,000, what we're going to do is we are going to think about replacing the prefix with its standard form. So here you can see the prefix is a K, because the M is the unit, meters. So 0.5 kilometers, if we want to replace that prefix, we know that the standard form for kilometers is times 10 to the 3. So what we can write is 0.5 times 10 to the 3 meters for that particular question. And that is perfectly converted. It might not be in correct standard form, but we don't need to worry about correct standard form in science. We just need our students to convert the units correctly. So what they've done there is they've removed the K and they've replaced it with its standard form variant. So this 10 to the 3 is where the K was, and they mean the same thing. K just means 10 to the 3. So we can do that then with millihertz. So if we remember from our prefix table, the lowercase m, milli, stands for 10 to the minus 3. So when we're converting to from millihertz to hertz, we just need to replace the m with its standard form, and we end up with 19 times 10 to the minus 3 hertz. So what I would like you to do is pause and just do the same for the 57 nanovolts and the 13 mega ohms. Okay, so hopefully you paused. Remembering our standard form table, we know that the n, nano, stands for times 10 to the minus 9. So actually we're just going to replace that nano with times 10 to the minus 9, and we end up with 57 times 10 to the minus 9 volts. And then again for question 4, 13 mega ohms. The mega stands for times 10 to the 6, so we end up with 13 times 10 to the 6 ohms. And that's perfectly fine for converting units. All of those units have been converted successfully. It isn't correct standard form, so a maths teacher might not be very happy with this, but that is good enough for our science exam. Our students have done it correctly. They can now type that number there into their calculator with the rest of their equation to get the correct result. So we can also talk about this when it gets a little harder, because converting units with standard form prefixes is relatively easy once we've remembered that table, but it does get harder with area and volume, as they are squared and cubed units. So what we need to do when we're converting an area is we need to multiply the prefix number by 2, because that accounts for the squared. And if we're converting a volume, we need to multiply that prefix number by 3 to account for the cubed. So if we're looking at this, then we've got 15 centimeters squared and 22 millimeters cubed. We need to convert both of those to meters squared. So in this case, we've got 15 centimeters. Well, we know that the centi stands for minus 2, or times 10 to the minus 2, sorry. So actually what we're going to do is we're going to replace it by times 10 to the minus 2 times 2 because of the squared. So you can see that we've written 15 times 10 to the minus 2 times 2, and that can simplify to 15 times 10 to the minus 4 meters squared. And in this one, we've got 22 millimeters cubed. Well, we already know the milli stands for minus 3. Because it's cubed, we're going to times it by 3, so we can write 22 times 10 to the minus 3 times 3. And again, that simplifies to 22 times 10 to the minus 9 meters cubed. So you can see, again, it's still easy to just replace the prefixes. However, this time it is slightly harder because we need to remember there is a squared and a cubed there as well. So that's really all you need to know for converting units. If you do have any questions, please feel free to leave a comment and we will get back to you. But hopefully you guys now feel a little bit more confident at passing conversion of unit skills on to our students. So thank you for listening, and we'll see you in the next video.